reorganizing the information into a vector of vectors because it'll make it a lot easier to find adjacent edges. So you're not creating any new information here, you're just reorganizing it in a way that helps you out. And in a way, it's kind of waste space because we're keeping the same information in two places, but this just makes life a lot easier for you. And there's not going to be so many intersections and road segments that this will make your computer slow down to like a crawl. You don't have to worry about that. But in other, like if you were doing this in some other application, you might have to think, oh wait, I have the same information in two data structures. Why am I doing that? Should I be doing that? Is it necessary? In this case, it helps us out a lot, so we're going to do it. However, one problem that we have is this whole mess, right? In that we had to start in the bottom right-hand corner, and I even wrote it down wrong the first time, the way the avenues were going. And when we talk about vector of vectors in every other lab, up here is 0, 0, right? And not down here. And so when you put in I equals 0, j equals 0, that can't be intersection 0, 0. That has to be the max, right? Let's take a look. You basically have to mirror your entire matrix, which can be a headache. So what I did is I completely changed all the rules, basically flip-flopped every single rule. And it makes it a lot easier to code. You just have to make sure you get it right at the very beginning. So what I would do is now that we understand how everything works with this, take out a piece of paper, draw your grid, and instead start with 0, 0 up here, and max down here, and then every rule is going to be flipped essentially, because we're basically taking this and reflecting it across the diagonal, right? So if we want to look at that, maybe right here on a miniature version. Okay, here's my city. And we were looking at zero, 0. Every odd was going down, but now I'm going to be looking at it. You can just take your piece of paper and basically turn it upside down if you wanted to. So if we have 0, 0 up at the top, if we look at it upside down, it's in the right place. So then just follow your rules upside down. It looks like 1 should be going north. And then 2 obviously is going to be going south. 0 is going to be going in both directions. And then if we had a 5, it would be going in both directions. And then our streets are going to be flip-flops. So street 1 was going this way. If you look at it upside down, it's going to the left. And this would be going to right. And this would be going to the left. So basically take what you just drew on a piece of paper, hopefully you drew it out, and turn it upside down. And it should work. And then you can take this vector of intersections and use it like you typically would in any other lab that you've done. All right. Computer's on its deathbed, so I'm just going to pull my notes up here. It's lab 8, right? Yeah. Okay, so we've talked about reading it in, finding the highest number street and avenue. Temporary vector. Okay, so have your vector filled in, remember this is just simply iterating through your all list and throwing them in where they should be because you have the street and avenue number as fields in the intersection. So once you've done that, once you have temp filled in completely, and what you're going to do is iterate through temp now. I'd use an I and a J for, let's do this as street and avenue. And iterate through all of them. And then look up. Look down. Look left. And look right. This is inside your temp iteration. Look up, down, left, and right. These should be some pretty heavy if statements. There's going to be a lot of things to check. First thing would be if you can actually look up as in you're not going out of bounds. So do all of your out of bounds checks and then say, oh, well, is this actually a road that travels up or not? Can I go north, essentially? So they should have a lot of if statements, and remember not to look at all of the bullet points at the very top for the rules to do that if you're looking at the map upside down, like I talked about. You'd have to flip-flop every rule, essentially. So let's do an example for like look down. Look down, we need to check if it's out of bounds. So looking down would be, let's see, these are my streets and these are my avenues. So how would I check to see if I'm out of bounds or going to be out of bounds if I look down? There's something useful that we already have.
If looking down is greater than Max Street.
Yes, so if Max Street is the last street, we need to make sure that I is going to be our streets, I is less than Max Street, right? If it's not, then you can't look down. So that's one thing that you need to look at. So as long as this is true and all the other crazy things with our rules is true, so something else we have to look at is if the avenue is even or odd, right? So J is the avenue, and if we mod it by 2, that's checking its even or oddness. But let's say we're looking at it upside down. Yeah. So if we're looking at it upside down, we can look down if it's even, right? Because this is 0, this is 2, this is 4. So you can look down if it's even. Does that match up with the upside down graph? Okay. So how do we check if it's even specifically?
1, 2, 0.
Yeah, so this is 0. Or,
It's divisible by 5.
exactly, if it's divisible by 5. So if J is divisible by 5, so mod 5 is 0. Or
It's the highest avenue.
it's the highest avenue, right? The streets don't get that special case. Or if J is equal to what? Max Ave, right? Max Ave. This is also.
Okay.
So that's specifically for our looking upside down style, just as an example. Yeah.
Got a question. Wouldn't the max Ave now be 0?
No, the max Ave is going
Because
to
you
be
flipped
the
it.
same, like, so let's say over here, the max avenue was, I went up to 5, right, so I did, oh, I drew a 5 over here. So 5 is still the max avenue,
Mhm.
it's just upside down, it's located on the right side instead of on the left
Okay.
side.
Okay. Alright.
have like the out of bounds checks as a first if statement, because you have an and here. This has to be true, and then all the rest of these have to be true. So you have to use like a bajillion parentheses. So I would just do out of bounds check for each one of these and do specific checks inside of that. And remember with your Max Avenue, that's only on avenues. You don't have a special thing for Max Street, that you want to make sure and get all of those exceptions in there. So you're going to have look up, look down, look left, look right. Inside those if statements, create your edge. And our edges are called what in this lab?
Road.
The road segments, yes. So if you can look up, or let's say you can look down and there is indeed an intersection beneath us, then you would create a road segment and fill in all the information, which is quite a bit of information. You can put the type in, whether it's a street or avenue, the number, the from, which is the current location you're in, and the to, which is what would be the next intersection you would get to by going down. And then you'll need to calculate the distance using the distance formula. And like I said, I went ahead and calculated the difference between the x's and the difference between the y's before I did that, which should be pretty easy because you're at temp I, j, and if we look down, then
Plus, you add the columns.
that would be looking at I plus 1, j, right? So just compare the distances, or the x values between these two. Since this is an intersection, then you can grab its x coordinate by doing arrow x. And this is also an intersection, and you can grab its x coordinate by arrow x. And if you take the difference between those two, that's your diff x that you would pull into your distance formula here, that you would end up squaring, adding to the y diff that's squared, and then taking the square root of it. So once you make all of your road segments and go through looking up, down, left, and right, then you're done with the constructor. So it's basically taking in all of your information by taking in all the intersections, putting them into the list, then transferring that data to a temp vector of intersections, then iterating through this and making all of the road segments. And then you're done with the constructor. So step by step wise, it doesn't seem that bad. It's just that you have a ton of information to fill in because all of the road segments have a lot of fields, all of the intersections have a lot of fields, you have a lot of really random checks that you have to do, so it takes a little while to code all of that up, but it's not anything incredibly difficult. It's just a lot of manual labor for your fingers, let's say. So Dijkstra's is the next thing that we're going to talk about, and it has a lot less code to it. Is everybody good with, I'm going to just erase this right here. I won't erase, let's see. So who knows if that's true or not, but it also can help you remember to spell Dijkstra correctly. Okay, so in Dijkstra we're going to be using the breadth first search queue that we talked about. It's actually multi-map, BFS Q. And I would take a look at the breadth first search notes to get a good idea of how breadth first search works. Did your arms get tired?
Yeah.
Yeah. So first thing that you're going to do in Dijkstra's is get a starting point. So you're going to insert the first, we start at 0, 0. IS for intersection into the queue to get our breadth first search started. You'll see that typically any breadth first search notes that you look at, you need to somehow get that breadth first search started. So this is the starting intersection. 0, 0. We'll put that into the queue to get it started. So then we're gonna take the first thing in the queue. First intersection in the queue. When we start, it's obviously gonna be 0, 0, but we're gonna be constantly adding stuff to the queue, as you know when we do breadth first search. So